All right. Hello, everyone. Today, talking about lesson 9.1, which is reflections. Okay. Our objectives today will be to draw reflections and to draw reflections in the coordinate plane. Okay. Main focus here is in the coordinate plane, but we do want to understand how to draw reflections when not in the coordinate plane. So, a reflection in a line. That's our key concept here. A reflection in a line, guys, it's a function that maps a point to its image. Okay, this idea of pre-image and image. Okay, if the point is on the line, then the image and pre-image are the same point. So you guys can see this example here. Guys, point A is on line K. Okay, so the reflection of it just stays on the line, guys. If a point is on that line, it stays on the line. Okay. The more common occurrence here is if the point is not on the line. So here, point A, the pre-image is not on the line. Okay. If the point is not on the line is the perpendicular bisector of the segment joining the 2 points. So the line K, guys, that is perpendicular to, and it is the bisector of the segment joining A and A prime. So those would be equidistant. Say it's 1 inch, on each side. Those are congruent segments, congruent pieces. Okay. So guys, you're gonna have to bear with me here. Usually, if I've got my yardstick in the classroom, this is kind of a little easier to demonstrate, but we'll do as best we can with the technology we have. So, guys, let's reflect this triangle ABC across line K. Okay, so what we're going to do, what we would do, we would measure the distance C is from line K. Whatever distance that is, we would continue on this segment that is perpendicular to it. So trying to estimate here, that's about the same distance. Okay, and we would plot the point C prime. That is the reflection of point C across line K. All right, and we would do similar to that here for point B. We kind of just continue this. So again, trying to be perpendicular to line K as best we can. Oh, a little off there. So maybe probably along that line, we would try to go to the other side and be about the same distance from it, where this segment would be congruent to that segment. And that would be our point B prime. That's the reflection of B in line K. And lastly, we would do this with point A. We would, again, try to find that segment that's perpendicular and find out what that distance is and copy it to the other side of line K. All right, and that would be the point A prime. So the reflection here, guys, is this triangle we have, A prime, B prime, C prime. Okay, so that is how you reflect. Again, the main points here of reflecting this, you want all of these segments to be congruent, and all of these segments need to be perpendicular, 90 degrees perpendicular, let's say, to line K. Apologize there. About to write that. Okay, perpendicular to line K. All right, so all those lines of those were perpendicular to line K, and we tried to make them the same distance from line K, which we were eyeballing it, guys. Like I said, if we had a ruler, that would be much easier. Okay, I've got another shape here on the next page that you guys could try this on if you wanted to copy this down. This is interesting because if you're reflecting across line N, guys, you've got one point to the left of it that you would reflect again to the opposite side. So that would be our point P prime. And then all of these other points that start out on the right of it, all of those points would reflect to the left side. Okay, again, using that same idea, perpendicular bisector, Q prime, R prime, and S prime. Those would all move to the left side. So, interesting example if you guys want to kind of copy something like that down. I think there's one or two on your homework where that could come up. Okay, where I wanted to spend the majority of our time, guys, was talking about reflecting in the coordinate plane. So, triangle JKL has vertices at 0, 3. Plot that point, J. K, -2, -1. And L, -6, +1. Okay, so this is triangle J, K, L. And it wants us to reflect the image in the given line x equals -4. So let me connect JKL here. So we're going to take this triangle and reflect it across the line. I'll use a different color here. X equals -4. Okay. So that line x equals -4, that is the vertical line that cuts through our figure. Okay, guys, reflections in the coordinate plane. Kind of nice. If you're reflecting across something that's vertical, guys, the perpendicular to that is going to be horizontal. So the point L, guys, that's you can count how far it is from the line x equals -4. It is, so this is that line x equals -4. It is 2 units, 2 units to the left. So the reflection of it would be 1, 2, that point right there. That would be the reflection of L across the line. It's 2 units to the right. And you're continuing this. So J, how far is it from this line? 1, 2, 3. It is 4 units to the right. So the reflection should be 1, 2, 3, 4 units to the left of our line of reflection. So we've got J prime, we've got L prime, K prime. Okay, so that is, if we're starting at the line, it's 1, 2 units to the right. So go back to our line, go 1, 2 units to the left. And there's where K prime will be. So using black again to connect these, we have reflected our triangle across the line x equals -4 using J prime, K prime, and L prime. Okay. And so the next example we have, if we're continuing, I'm going to need to write down my coordinates here. J is 0, -2, -1. It's another example in the coordinate plane. Okay. We're going to take that same triangle, 3, K is, I'm going to have to go back and forth here. And L was -6, +1. So we're going to take that same starting triangle and reflect it across the line, y equals 2. So J is at 0, 3. K, -2, -1. And L, -6, 1. Struggling drawing straight lines. Apologize there, guys. So we're reflecting across y equals 2. So we have that line y equals 2. That is the horizontal line here. That goes right through our triangle. Right? So rather than going left and right, guys, you can imagine now we're to reflect J across that line, we're just counting, well, it's 1 unit above, so the reflection would be 1 unit below. For K, it is, so starting at the line, it is 1, 2, 3 units below, so the reflection should be 1, 2, 3 units above. So there would be K prime. And lastly, guys, L is 1 unit below, so its reflection, L prime, would be 1 unit above. So if we connect J prime to K prime and L prime, you can get a pretty clear picture there of our reflection across to y equals 2. All right. Guys, lastly, we might reflect a point in the line y equals x. Guys, that's the line that just goes through. I mean, you can see it graphed here. It goes through the origin. It has points like 1, 1, 2, 2, 3, 3. It has those points on it. Okay, that's the line y equals x. And so how you do that, guys, you just flip the ordered pair. So if point A is, in this example, point A was -5, 2. So if you were reflecting in the line y equals x, then A prime, you flip the ordered pair, 2, -5. And you can see that in this picture, how that reflects it across the line y equals x. Okay. So one more example, guys, here on this last page. We're going to take the quadrilateral JKLM with vertices at 2, 2. I'm going to write these down as we go. K is at 4, 1. L is at 3, -3. And M is at 0, -4. Okay. And we're going to reflect this across the line y equals x. Again, that line is, that's the points 1, 1, 2, 2, 3, 3. Okay, -1, -1, -2. So that is the line we're reflecting across. It's the line y equals x. So, guys, if you remember that pattern, the XY ordered pair, to flip that, or to reflect it across y equals x, you just flip the ordered pair. So J prime, the image of J would be, well, it's actually funny. If you flip the ordered pair, it is still 2, 2. Okay? That kind of goes back to that first point. If a point is on the line of and M prime would be at -4, 0. Connecting all of these, it looks like a very clear reflection of our original triangle, our original quadrilateral. I apologize. So guys, your homework, page 627, 10 through 14, you guys, show all of those work, show each problem's work, and take a picture of it, upload it into the Canvas assignment, and we'll see you again tomorrow. Everyone have a wonderful afternoon.